We are going to study a very important topic of AS level physics, and the topic is kinematics. In kinematics, there is a subtopic which is projectile motion. This projectile motion we have not studied in O level, and this is serial 9 of equations of motion. First of all, I'll give you the definition of a projectile motion. Every object moving horizontally at a constant velocity and moving vertically under the gravitational acceleration is called a projectile. It is a two-dimensional motion. Please remember that when we are studying projectile motion, till the time I do not say that friction is going to be considered, we are ignoring air friction. Examples of projectile motion are innumerable, but I am going to talk about a few of them. Number one is a footballer kicking the football in air. I have shown the diagram. If the footballer intends that the football should fly in the air, then he has to kick it at an inclined angle from the ground as shown in green color. Number two is stone being thrown in air. Number three is shell being fired by an artillery gun. Number four is bullet being fired by rifle or pistol. Number five, a sphere rolled on table top which falls from edge of the table and becomes projectile. Because the moment it leaves the edge of the table, it is going to be acted upon by gravity. Similarly, if a stone is being thrown, the moment the stone leaves the thrower's hand, gravity will start to act on it and it will become a projectile. The shell which is being fired by artillery gun, the moment it leaves the barrel becomes a projectile because it has no force which is pushing it after it leaves the barrel, and the gravity starts to act on it as it leaves the barrel. Bullet, when it leaves the barrel of the rifle or pistol, it will also be acted upon by the gravity and it will become a projectile. Please remember that since the velocity of the shell or bullet is very large, so the effects of gravity are very minimum because time of flight is very small. However, they will be acting as projectiles till the time they go and hit the target. Now, if an object is thrown vertically upwards in such a manner that it goes up and comes down at the same point from where it was thrown, that means it didn't have a horizontal velocity and it has not traveled horizontal distance, so this type of motion will not be called a projectile. Rockets and missiles, they have their own propulsion system. For example, there are fans and turbines and fuel systems that burn out even when they have been fired, and since there are external forces acting on it even after being fired, so they are not projectiles. Now, I have made a diagram for you at the bottom of the page, almost center of the page, and in that diagram I've shown you the trajectory of the projectile from O to Q. Now, there are certain terms that we are going to learn for the projectile motion. Number one is R, and R, capital R, and r is range of projectile. It is horizontal distance between start point and landing point, which is shown from O to Q. H capital is the total height gained from P to R.
S.
Remember that the body is moving from O to P horizontally and P to R
S.
vertically, that is in 2 dimensions. Please remember that P is an imaginary point on the ground just below R, where the projectile has achieved maximum height. Small u is the initial velocity with which the body is projected at point O. It is an inclined velocity. Ignoring losses, the velocity at landing point Q will be same but inclined in opposite direction as shown in the diagram. Can you see the red arrow? It is almost the same angle as at O, but the direction of the velocity u is downwards inclined. Note that u is tangent to trajectory at O, R, and Q. From O to R, u sine theta is vertical velocity at O upwards continuously reduces and becomes 0 at R. From R to Q, vertical velocity increases from 0 to minus u sine theta at Q. Negative sign is due to reversal of the direction because velocity is a vector quantity. Then on next page is time of flight, capital T. It is the time taken by the projectile from O to Q. Half time of flight, small t, time from O to P or P to Q. So we can say that capital T is equal to 2 times the small t. Point P, the point where height is maximum, here vertical velocity is 0 momentarily. Now we discuss the equations for calculation of h, t and r. H is equal to u square sine square theta divided by 2g. Capital T is equal to 2u sine theta over g. R, the range, is equal to u square sine of 2 theta over g. R will be maximum when theta is equal to 45 degree because sine of 2 theta is equal to sine of 90 is equal to 1, and then our maximum will become u square over g. Examples on projectile motion. Example number 1. A bomber flying horizontally at a constant velocity of 50 meters per second at a height of 1000 meters drops or releases a bomb. At what distance before the target on ground should the pilot release the bomb so as to hit the target? Now I have explained the situation in sketch form. The height is 1000 meter and the distance capital D we have to calculate. The horizontal velocity of the aeroplane or the bomber is 50 meters per second. On the right side I have written the data and the requirement. You must write the data for solution so that all the information given in the question is available to you. Now in this question theta is not given, so we can use equations of motion simply. We know that initial velocity downwards is 0 meter per second and gravity is equal to 9.81 meter per second square. So we can calculate time to reach the ground. From h is equal to ut plus half gt square. Putting in the values, h 1000 meter and g 9.81, the time that is calculated is 14.3 0.278 seconds. Remember, never round off in between the procedure of a numerical, but in the final answer you can round off the answer and write in standard form, or keeping in view the number of significant figure. Using information that horizontal velocity remains constant in a projectile motion, we can use the equation of average velocity to calculate d. We know that average velocity is equal to distance over time. So here u horizontal is equal to capital D over t, and d will be equal to the product of u horizontal and t, and we find out that distance before the target would be 713.9 meter, which is almost equal to 714 meter. In this numerical, there could be another part in which the final velocity or resultant velocity would have been asked when the bomb hits the ground or target. And you know that we could use the vertical component, and in which we could use v is equal to u plus gt. We already have calculated t, and we could find out the vertical velocity when the bomb hits the target. Now on ground, the vertical velocity having been calculated, we have the horizontal velocity, and it would make a right angle triangle, and we use Pythagoras theorem to find resultant vertical velocity when the target is hit by the bomb. Now we go to example number 2, in which a ball is thrown at an inclined velocity of 50 meter per second, such that its horizontal velocity is 30 meter per second, and we have been asked to calculate the range and the maximum height. Now in this we are given the two velocities, so we can find out theta. We know that u cos theta is equal to 30 meter per second, and u is 50 meter per second, so we use 50 cos theta is equal to 30, and cos theta is equal to 30 over 50, and from there we find out theta is equal to 53.13 degrees. So for calculating the range, capital R, we use formula r is equal to u square sine 2 theta over g, and put in the value 50 square sine of 2 times 53.13 is equal to 50 square into 0.96 over 9.81 is equal to 244.6 meter. So we find out range equal to 244.6 meter, which must be written in the place where the answer is to be given. And secondly, formula of capital H is u square sine square theta over 2g. Again putting in the values, we find out that H is 81.55 meter, and we write the answer of H equal to 81.55 meter in the required place, and we have solved the numerical. Here I finished the teaching of projectile motion. I will request my viewers and the students to kindly subscribe to my channel so that I can keep on uploading various lectures on other topics which are very important for A-level physics.